All right, we're going to go ahead and review solving equations by addition or subtraction. In the following topic, we went over expressions. So if you recall, an expression did not have an equal sign. And now for this case, we're going to be going over solving equations, which will have an equal sign. An expression is not solved. An expression is just simplified, whereas an equation would be something that we are solving for. We're trying to find out what the value is for x. I should state an expression is only simplified when we are plugging in that value for x. This expression here is already in simplest form. So when we are solving an equation, what we're ending up solving for is that solution of an equation. Sometimes solutions are written in a solution set, and a set is a collection of objects or numbers that is shown using braces, and a solution set is the set of elements or numbers from the replacement set that make the equation true. We have the addition property of equality, and what the addition property of equality states is that if we take a value and set it equal to something that it's equivalent to, for example 14 equaling 14, if I add 3 to one side and I have to add 3 to the other side to keep them equal. And the same thing goes here. If I'm adding 9 to this side, I would have to add 9 to this side to keep it equal. So pretty much for any number, like for example here, A and B and C, if A is equal to B, so if A is set equal to B and we decide to add C to it, we would have to add C to it, and these could be any real number. So this same concept we do when we're solving for equations. So if there's subtraction happening with the variable, in order for us to get this variable alone to solve, we have to do the addition property of equality, which is the inverse operation. To get rid of subtraction of 22, we would have to go ahead and add 22. A lot of times I will highlight or put a box around the variable to show what I am solving for. So now I'm going to get C alone. So the inverse operation of subtracting 22 would be adding 22. And if I do it to one side of the equal sign, I must do it to the other. These are inverses. They cancel each other out. And I have C is equal to 76. Because when I add 54 and 22, I get 76. Next we have J minus 87. And so I want to, is equal to -3. I want to solve for J. I need to isolate J. The only way to do that is to do the inverse. And what I do to one side, I must do to the other. I add 87. And now J is equal to, if you notice here, these have opposite signs. When they are opposite, we subtract, and then we keep the sign of the larger. So I have 87 minus 3, which is 84. And because 87 is larger, this will be positive. All right, next we have 2/3 equaling R minus 1/3. Now I'm used to seeing the variable on the left side, but sometimes it's on the right side, and that's okay. We solve it just the same. I do want to isolate R, so in order to get that alone, I need to do the inverse of subtracting subtracting 1/3 and add 1/3. And what we do to one side, we must do to the other to keep it equal. These are inverses, so they cancel each other out, and I have 2/3 plus 1/3. Remember, when we're adding a fraction, the denominator must be the same, and in this case it is, so I'm left with 3/3 equaling R. However, this is not simplified, and we always must simplify a fraction. 3 divided by 3 is 1. Anything by itself is actually just 1. I'm going to also put that as a side note. I said it, but I want to keep this as a reminder and something that we remember. We must always simplify. It's really important that you add that to your note because that's something that must always be done with a fraction in math. Sometimes you're asked to check your work, which actually you would have to show by plugging this back in, and we'll review this when we go over some of this in class. However, the way you do that is if I'm solving here and I say that C is equal to 76, replace C with 76. 76 minus 22 is 54, so that works. Here I would replace J with 84. And 84 minus 87 is equal to -3. And here for this last one, I would plug in 1. Now remember, 1 is also the same thing as 3 over 3, and 3 over 3 minus 1/3 is 2/3, therefore 2/3 is equal to 2/3. Okay, next we have the subtraction property of equality, and that works exactly the same way as the addition property of equality. The only difference is now if we have something being added to the variable, we're going to do the opposite now. We're going to undo that by subtracting that number. So I want to, remember, I highlight my variable that I'm solving for. I'm trying to get m alone. So I need to do the inverse of adding 63, which is subtracting 63. And what I do to one side, I must do to the other. Inverses cancel, and I'm left with m equaling 16. Remember, we can always check our work. If we plug 16 back in, 63 plus 16 is equal to 79. So we did get that correct. Next am going to solve for p. The variable's on the opposite side. That's okay. We solved just the same. The opposite of adding 16 is subtracting 16. Inverse operations, what we do to one side, we must do to the other. These cancel each other out, and I'm left with p equaling. Now, when they're the same sign, we add and keep the sign, because think about this. If we're at -12 and we're going back another 16 spots on the number line, we're now at -28. I do like to rewrite this where my variable is in the front because I am solving for the variable, I'm not solving for the number. To check my work, I can go ahead and plug this back in, and I do have -28 plus 16, which does give me -12. All right, moving on to the next one, I'm going to isolate my variable. I'm trying to solve for x. I need to do the inverse of adding 2/10, and now I'm going to subtract 2/10. What I do to one side, I must do to the other. Inverses cancel. 9/10 minus 2/10 is 7/10. Like I said, I do like to write my variable first because that is what I'm solving for. And to check my work, I could just plug in 7/10 in for x, and 7/10 plus 2/10 is equal to 9/10. So that does work. Next, we're going to go ahead and translate equations, and we're actually going to use the same exact vocabulary that we used in 1-1, where we had different words that represented the meanings for addition, subtraction, multiplication, and division. Now, there is going to be a slight difference because now we're dealing with equations rather than expressions, so we do have an equal sign that's going to be included in these, and some of the different words that you can see that will represent an equal sign, for example, are is, as much as, is the same as, is identical to. So when you see that word is, you will know that represents an equal sign. All right, so example 3, translate each sentence into an equation. We have 7 times a number squared, so is 5 times the difference of k and m. So we have 7 times a number. Remember, times, that means multiplication. So let's go ahead and write this. We have 7 times a number. They didn't give us a variable here. We can use x. We can, for me, I'll just go ahead and put n. So 7 times n. And that number is squared. So 7 times a number squared is, remember, that's an equal sign, 5 times the difference of k and m. So it's 5 being multiplied by the difference of two variables k minus m. I do have to put this in parentheses and show this because it's 5 being multiplied by the difference. So I have to find the difference of these two values before I can multiply by 5. All right, next we have 15 times a number. So we'll go ahead and just use n again, why not? Subtracted from 80. So 15 times n is actually subtracted from 80. So it's taken away from 80. Is 25, is the key word, so equals 25. What I'm doing is I'm just translating each word at a time. Same thing as if you were translating from one language to another. You would do it from one word at a time if you're translating to be able to understand what a sentence is, perhaps in Spanish or French. So what we do is we just break it down one word at a time. We have just one more example, which is actually our word problems. It says Mr. Hernandez loaned Sophia $32 to buy her homecoming ticket for the dance. At the end of the year, Sophia ended up owing Mr. Hernandez $91. Write and solve an equation to find the total amount Sophia owed Mr. Hernandez at the end of the year. I think this is worded a little bit wrong. This should say owed. I think it means for us to find out the additional amount that she had owed. Maybe not. Just the wording of it doesn't make sense, but based on breaking this down and just having an understanding of this, we are going to write and solve an equation. So the equation itself, and then the solution of the equation. So two things, right? So we're trying to find out, he already loaned Sophia $32. So that's something that she owes, right? That's in the negative. So it's $32. And so far, Sophia ended up owing, at the end of the year, she ended up owing Mr. Hernandez $91. I think that this is a little bit wrong. I think that she had already owed him $91. Now she's got to owe another $32. So we're just trying to solve for whatever that missing value is that brings the total amount to what she owes by the end of the year. So there is a little bit of a wording issue here. I do apologize. So this is the equation written as per what the problem is asking us, but it also wants us to solve the equation. And the way we would solve this is to do the inverse of subtracting 32, and we would add 32. Inverses cancel each other out. We have that x is equal to 123. Remember, dollar signs are written before. So this is actually our equation solved. This is the end result of what Sophia will owe Mr. Hernandez. So next we're going to go ahead and work on that independent practice. I would like for you to go ahead and try this on your own, and we then can review this together.